All right, in this question, we have to replace this system of forces and moments with a single force located along a vertical line at x equal to 10. Okay. So, as usual, the first port of call here is to work our way through each of the forces here and work out if it's not aligned along the x or y axis or parallel with the x or y axis, we've got to work out its vertical and horizontal components. So I'm going to rattle through these relatively quickly next. So we'll start with force A, the 120 newtons, located at point 87. All right, so just sketching it out again. We've got the usual story here. We've 120 times the cosine of 60, and we have 120 times the sine of 60. So we've got 60 newtons for the horizontal component, and we've 103.9 newtons for the vertical component. Now, while we're here, I'm going to work out what is the moment effect, the moment influence of that force about the origin. So we'll call it M sub A, and that's going to equal the horizontal component. It has a lever arm of 70. About the origin, it would generate a clockwise moment, so it's positive. And then the vertical component will generate a counterclockwise moment, so therefore it's negative 103.9 times 8. Its lever arm. Okay, and so the moment effect of that guy is a negative 411.2 Newton meters. All right, so let's just summarize that here. So we'll say Fxa 60 newtons, Fya is 103.9 newtons, and Ma is minus 411.2 Newton meters. Okay, so let's put a box around that and move swiftly on to force B. All right, so the horizontal and vertical components are 61.4 and 43, and the moment in this case we'll call MB, and that's going to equal the 61.4 times the lever arm of 3, positive moment, plus the 43 times a lever arm of 14 meters. Okay, and that's that's positive as well. Okay, and that's going to give me a moment of 786.2 Newton meters. All right, and we can summarize that. Okay, we'll move on to force C. Okay, so there we have force C. Next, we'll move on to force D. Now, force D is, we'll just remind ourselves, force D is this guy here acts vertically, and so we won't even draw that one out. That's pretty straightforward. The moment that force D generates about the origin is a counterclockwise moment, and so it's negative, and it's going to be it's going to have a magnitude of 150 times 12, which is 1800 Newton meters. So we'll just summarize that without a sketch. Okay, so the final force component we need to look at is E. All right, at this point we can work out the sum of the forces in the x and y direction next. So we'll say the sum of the forces in the x direction, and that's just a matter of going and counting up all of our horizontal force components. So we'll have 60 plus 61.4 minus 187.9 plus the 58 is going to give us a negative 8.5 newtons, and then the same thing for the y direction. We've got 103.9 minus 43 plus 68.4 minus 150 plus 15.5, and that's going to give us a negative 5.2. Alright, so at this stage you know where we're going next. We got to work out the magnitude of the resultant force. So that's just going to be the square root of 8.5, negative 8.5 squared, plus a negative 5.2 squared. Alright then, and that's going to give us 10. Alright, and now let's just work out the angle of orientation of that force. So we have a horizontal component of negative 8.5, because the arrow, in this case the arrow is indicating the direction, so we'll just show the magnitude for the length of the arrow, so a positive 8.5. Now we've got a negative 5.2, so that's a downward pointing arrow, and now we can sketch on the resultant. So we'll call that F4, which we've already worked out to be 10, and we'll call this angle in here beta. Alright, so simple enough, the tangent or tan of beta is equal to 5.2 over 8.5, which should give us beta equal to 31.5 degrees. Okay, so we fully defined the force, the equivalent force. We've got to now just sum up all of the moment effects or the moment influences of all of those individual forces to work out the combined effect. So we'll say the sum of the moments is equal to, and again, we're just counting up the moments we've already evaluated. So that gets us 546.2 Newton meters. Again, a positive number is indicating that that resultant moment is a clockwise moment. All right, so remember what the question asked us. So let's remind ourselves here. So the question said, let's replace this system with a single force located along a vertical line at x equal to 10. Okay, so we need to generate a clockwise moment of 546.2 Newton meters. Right, so let's just, let's write out an equation for that moment. And we're imagining, let's just sketch out our axis system here, right? So our axis system is something like this. Now we said, there's a vertical line, imagine a vertical line at x equal to 10 here, and we need to position our resultant force, which we know, remember, has a horizontal component of 8.5 and a vertical component of 5.2. That's got to be positioned somewhere along that dashed red line. Okay, now we need to generate a positive moment. Let's start off by just writing an equation that is going to define or give me the moment generated by the force. So let's just assume for now that the force is located here. Right, so we had a horizontal component of 8.5, we had a vertical component of 5.2, and we know that those two components generate a moment about the origin. Equally, we know that that distance there is 10. So the equation for the moment generated about the origin would be this, right? It would be, let's see, the 8.5 times some lever arm. Let's call the lever arm lambda. We don't know what lambda is yet, so that's going to be lambda, right? So that's going to be a positive moment, so that's plus. The 5.2 also generates a positive moment, so that's a plus. 5.2. Now, its lever arm is the 10, right? So that's 5.2 times 10, and that's all equal to, it's got to equal to 546.2. All right, and at this point, folks, it's fairly straightforward. We just got to solve for lambda. So when you solve for lambda, you should get 58.1 meters. And there you have it. That's your answer. So if you have to put your force somewhere along that line at x equal to 10, that was specified in the question, we'd have to shift it in the negative y direction 58.1 meters in order to generate the moment that we need to generate. All right, so there you have it. We've pretty much wrapped up everything that we're going to do on equivalent systems. So hopefully you found that helpful. You've had plenty of practice now. Moving forward, we're not going to be spending much time on these sort of abstract systems of forces and moments. We're going to be applying everything that we've learned in this section in a more practical context, applying it to model structures. So if this all felt a little bit abstract and without purpose, rest assured as we progress, you're going to see the practical application of everything that we've covered in this topic. Right, so we'll leave it there.